Right. Here we go, last page of what feels like 1,000 videos here. Unit 3, section 5 of our, I guess, trig material. This one, a little bit different. So we're kind of stepping away from the unit circle on this one. And it's all about these things we call sectors and arc lengths. So if we just kind of, before we jump into this, if we just want to begin with, what is a sector? What is an arc length? Think about a circle, all right? We know circles are defined by the radius. The radius goes from the center to the edge. We know the area of a circle is just pi r squared, right? We know the circumference of a circle is 2 pi times the radius, right? So those are kind of the two formulas. What we're doing differently on this one is we're not looking at the full circle. We're looking at just a piece of it. All right. And this piece, this is, think of like, a piece of a pie or something. How much of that pie is there? Well, all we have to do is we have to think about, well, what angle does this make? Right. So I'm going to throw a theta right here because how big that angle is depends on how big the area is. Right. If we want to think about this in terms of degrees, there are 360 degrees in a full circle, right? So all we have to do is we just have to take that theta, right, whatever that central angle is, and divide it by 360. And that gives us the fractional piece of the area of that circle, right? Similarly, so that now turns this into, I'm going to call this, what am I going to call this? I'm going to say A with a little s, the area of the sector. Right? Now the next one is the arc length. I'll use a different color for that. I don't know why, but we use the letter S to represent an arc length. That is just, think about the crust on the pizza, right? How long is that crust? Or, think about a track. You're running around a track. How far is, that percentage, that fraction of the track? Same idea. Look at that central angle, right? And divide it by 360. Those are the formulas we have for the area of a sector and then the length of an arc length, right? And keep in mind, this is in degrees. So if we want to kind of go from degrees to radians, let's think about this. All right, so we know the area of a sector is theta over 360 times pi r squared, right? Well, we know that 360 degrees is equal to 2 pi. So here's what I'm going to do. I'm going to take that 360 and I'm going to swap it out. And I'm going to say, all right, well, how about this? Theta over 2 pi equals pi r squared. Right? And if we just kind of simplify this formula, right, the pi's go away, and we're just left with 1/2 theta times r squared, right? That gives us the area of the sector. Right? So again, this is our degree formula. And this one is our radian formula. You just have to look at the problem and figure out, okay, what are they giving us? Which formula should I use? So that's the area of a sector. If you want the arc length, same idea. So we're going to say S equals theta over 360 times 2 pi r. So if we want to convert that, we're just going to say theta over 2 pi times 2 pi r. Right? Now, if you notice on this one, both the 2 pi's cancel out, and we're just left with theta times r. So the arc length is just theta times r, right? So it's a much more simple formula when we have radians. So this one is your degree. This one is your radian. Really, and that's all there is to it. We could simplify the degree one a little bit, but is it going to make it more helpful? I don't know. It just kind of depends. But these are the two, or I guess you could say four formulas we have for this section moving forward. All right. So on this first one, it's always helpful to identify just what you have. The radius is equal to 11, or central angle in this case is 17 pi over 12. All right, so notice this is a radian, so we'd probably be better off using the radian formula. All right, so we know the arc length, S, is just theta times R. All right, so just plug everything in. We have 11, no, we don't, we have 17 pi over 12 times 11. All right, let's punch all that into our calculator. 17. It's always something. 17 times 11. And then I'm going to do divided by 12. All right, that's going to give me some decimal. I don't want that decimal. Let's do math, turn it into a fraction. And then we have 187 twelfths. So this equals 187 twelfths. And then don't forget about that pi. So I'm going to put the pi back on top. That is the exact arc length. So 187 pi over 12. Now, when they want a rounded answer, right, just take that fraction, 187 twelfths, multiply it by pi. Again, let's use the pi button here. And then we're going to have 48.90, we'll say 48.96. Right? And there you go. That's how we find the arc length. We have the exact, and then we have the rounded. All right, so the area of the sector, now, I'm going to say A area of sector equals 1/2 times theta times the radius squared. That's going to give me 1/2 times 17 pi over 12 times the radius squared. That is 11 squared. All right, so there's a lot going on here. So let's do this. All right. So with fractions, always multiply all the tops together. I'm going to take that 11 squared. I'm just going to throw it on top. All right, so the top of the fraction is 1 times 17 times 121. 121 is just 11 squared. All right, so that's 2,057. So this equals 2,057 pi over 24. I got the 24 because, it's just 2 times 12. Now, we should try to reduce that fraction. I'd be willing to bet it doesn't reduce, but I'm going to try anyways. So just divide it by 24, right? 2057 divided by 24, some decimal, turn it into that fraction. Press math, press enter twice, and then, no, it does not reduce. And that's okay. And so you got 2057 pi over 24. Right? And to figure out the exact value, just multiply this fraction by pi, and that's going to give us 269.26. And that one's done. This, if we wanted units, this is square inches. This one is just normal inches. All right. Let's see the next one. Let's see, we got 3 more here. Oh man. All right, this one. These are in degrees. So the radius is 9. Central angle is 105. All right, so the arc length here, we're going to say S equals 105 over 180 times pi times 9. All right. So to get the exact value, this is where we can just, rely on our calculator a lot. 105 divided by 180. And then I'm just going to multiply that by 9. All right, so 5.25. If I turn that into a fraction, we're going to have 21 fourths. So this is 21 pi over 4. So that is the exact value Remember, exact means no decimals. We don't round it, right? But the rounded one, you just take that fraction, multiply it by pi, and we're going to have about 16.49. And then the last one, the area of the sector is going to be equal to 105. I made a mistake. All right, I need to fix that now. This should have been 360 degrees. All right, so let me fix that. It's 360, which honestly, we can do this. We're going to make this, I doubled the bottom on the first one. I need to double the top or the bottom on that one. So that should be 21 over 8 pi. 21 over 8 pi. And then I need to chop this in half. So this value, I need to divide by 2, and that's going to give me 8.25. Oh man, sorry about that. So that is centimeters. So 8.25 centimeters. The next one, back to it, area of sector, central angle, 105 divided by 360 times pi times 9 squared. 9 squared is 81, right? So top of our fraction, 105, right, divided by 360. Right, going to multiply that by 81. Gives me some decimal again, kind of ugly. So turn it into a fraction. That's 189 over 8. Right, that is your exact value. Right. Throw it in your calculator, multiply it by pi. Gives you 74.22. 74.22. All right, there we go. Let's see here. The area of sector is 78 pi, and the radius of the circle is 12 inches. What is the central angle of the circles? All right, so a couple things going on here. Central angle, it's not specifying for degrees or radians. I think the radian formula is a little bit easier. So we know the area of the sector is equal to 1/2. Is it beta r squared? We are looking for theta. All right, so plug in everything you know. We have a 78. That is the actual area of the sector. So 78 pi. It's going to equal the 1/2 stays 1/2. We don't know the central angle, so keep it as theta, right? But we do know the radius. The radius is 12 inches. So we have to take that 12 and square it. So if we wanted to just kind of keep going, we have 78 pi equals 1/2 times theta times 144. Right? Simplify it further, 78 pi equals 144 times 1/2 should give us 70 something. I think it's 77. 72, how about that? Equals 72 times theta. That means theta is 78 pi divided by 72. And that is a fraction we can reduce. That is 13/12 equals 13 pi over 12. If you wanted to convert that to degrees, multiply it by 180. Get rid of the pi. And that's going to be 195. This equals 195 degrees. All right, that one's done. Number 43, if the central angle of a circle is 3 pi over 4 and creates an arc length of 6 pi, what is the radius of the circle? So arc length, use the arc length formula. So we know S equals theta times R. All right, so the central angle, 3 pi over 4, arc length, 6 pi. So we have 6 pi equals 3 pi over 4 times the radius. All right, so first things first, pi is going to cancel out. And so 6 equals 3/4 times R, multiply both sides by 4/3. All right, then you're going to have 8. So your radius equals 8. That one. All right, and that one's done. That was page 5 of the Unit 3 test review. So hopefully that answered all of your questions. Hopefully I didn't go too fast. If you have any more questions, feel free to ask me, of course, all that good stuff. So good luck on your test, guys.